Okay, this is part 2. Let's work on that math worksheet number 25, limits and infinity. And let's start with letter G. Letter G says the limit as t approaches infinity of tangent of t. Well, the tangent graph is periodic. It just keeps repeating the same thing over and over again. Therefore, as x gets bigger and bigger and bigger, we can never discern a limit. And this limit does not exist. So now letter H. This one is quite interesting. So letter H has the limit as u approaches infinity of the square root of the expression 16u squared minus u minus 4u. Now there is a way to do this intuitively, but would like to take a second and show you how to do it algebraically. So really what we want is to be able to use our rules. Our rules such as 1 over a very big number is going to lead towards 0, and a very big number over anything else is going to lead towards infinity. So to do that, we really need to have rational expressions. We really need to have fractions. So let's factor out something so that we kind of have fractions here. So I'm going to factor out a u. And if you're not familiar with this technique, just kind of follow along. So if I factor a u out of everything, let's just put 1 over u here times 16u squared minus u. And then what is it if you factor a u out of negative 4u? Well, you just have negative 4, because that's outside the radical. So would you agree that if I distributed my u, I would actually have exactly what I started with? Okay, so all I did is factored out a u, and I have really an equivalent expression. So now let's make this a little more useful. Let's get this u right here under the radical. So if 1 over u were under the radical, and it came out of the radical as 1 over u, then when it was under the radical, it must have been 1 over u squared times 16u squared minus u minus 4. Again, if you took this out from under the radical and then distributed, you would have exactly the same expression we had when we started. So the next step would be to distribute this. So we have square root of 16u squared over u squared minus u over u squared. And then we didn't have to do anything with that 4, so that's just right there. Well, now we have limits that we can deal with. This one is going to be infinity. Right? As u approaches infinity, well, u approaches infinity. 16u squared over u squared, well, the u's, since they're the same exponent, you use the ratio of the coefficients. That's going to be a ratio of 16 to 1, so that's going to be 16. And here we're going to have a number over a larger number, so that's going to go to 0. As the bottom number gets bigger and bigger and bigger, this is going to go to 0. And then this just goes to 4. So what do we have? We have infinity. Let me scoot this a little. We have infinity times square root of 16 minus 4. That equals 0. So again, we factored out the u so that we had these rational expressions and we could sub in. We got to 0. Let's look back at the original problem and see if we could have done it logically. Well, as the big numbers go towards infinity, this u is going to matter less and less. Okay, so really, if you think of u squared as having a degree of 1, like if you take the square root of u squared, it's u. So what we really have here is a u and a u. And actually, root 16 is going to be 4. So we really have 4u minus 4u. Because as we get bigger and bigger, the single u under a radical isn't going to matter. So basically, as we get bigger and bigger, we have the square root of 16u squared minus 4u. It's going to go towards 0. So you could have done it intuitively, or you could have followed all the steps. The next problem is one that I think we will do intuitively, letter I, and it is the limit as x approaches negative infinity of x plus square root of x squared plus 2x. So as we get bigger and bigger and bigger, this 2x is going to matter less and less and less. But this x squared and this x are actually equivalent, right? Because if you take the square root of x squared, you'd get x. So these have the same exponent. So what happens as we get toward negative infinity? This x becomes a really big negative number, right? Think of what happens if I sub in negative 1,000. Plus the same really big negative number squared and then square rooted. So actually, if I square it and then square root it, if I square it, it becomes positive, doesn't it? So I'm going to get a positive square root. So I'm going to have this really big negative number plus the positive version of that number. So I'm going to get 0. Right? So this could be, for example, negative 1,000 plus the square root of negative 1,000 squared would be negative 1,000 plus positive 1,000 equals 0. Okay, so again, we're going towards 0. The real value of this is slightly bigger than 0 because of that 2x. But limits are just looking at what we're going toward. So now let's do letter J. J is the limit as x approaches infinity of 1 minus e to the x over 1 plus 2e to the x. So the quick way to look at this is just to say, hey, these are basically equivalent. So we can take the ratio of the coefficients. So it'd be negative 1/2. It's a really quick way to look at it. You don't have to worry too much when you see an e in a limit problem, because e is just a number, just like pi is just a number. So we're taking some number and raising it to a big, big power. And we're taking the number in the denominator and raising it to a really big power. So these ones end up not mattering so much except for the sign. So what we end up having is, this is the long explanation, 1 minus a really big number over 1 plus 2 times a really big number. So that's how we get the negative 1/2. Okay, finally letter K. This is the limit as t approaches infinity of t squared minus t to the 4th. Well, if we plug in a really big number here, we're going to have a really big number squared minus a really big number to the 4th. So this one is going to dominate, isn't it? And it's negative. Right? This one will always be bigger. So as you get really big, your answer is always going to be negative. So this must go towards negative infinity. So it's dne, comma negative infinity.